Astronomers just confirmed they are looking at something burning brighter than physics says it should be able to. They announced it on January 28, 2026. Light from a galaxy that existed 280 million years after the Big Bang, 2% of the age of everything. If the universe were a person who just turned 80, this galaxy existed when that person was about a year and a half old. We expected the early universe to look thin, dim, a handful of gas and dust, still figuring out how to become something. What the James Webb Space Telescope found instead was already burning far brighter than its age should allow. They called the survey that found it Mirage or Miracle, because before the team announced anything, they needed to know which one they were looking at. It turned out to be the second one. This is the true story of MOM-Z14, the farthest thing anyone has ever confirmed seeing. Forget a spacecraft for this trip. There is no engine fast enough, and there never will be. The only way to reach MOM-Z14 is to let its light do the traveling. That light left the galaxy 13.5 billion years ago. Hold on to that number. It sounds like the answer to how far away this galaxy is. It isn't. Not anymore. It has been stretching the whole way since, pulled longer and redder by the expansion of space itself. Eventually, the color slid out of anything human eyes could ever register and dropped into infrared. Part of why it took a telescope built to feel heat, not just see light, to catch it at all. 18 gold hexagons, folded up for launch and unfolded in deep space, finally caught what was left of it. Webb's mirror is 6.5 meters wide enough to gather a whisper of light that has been fading for almost the entire life of the universe, and still resolve it into a shape. Not a blur, not a smudge anyone had to argue over. An actual shape. And what arrived wasn't just a point of light anymore. It had size. A galaxy with a radius of about 240 light-years, roughly 1% the radius of the Milky Way. Small enough to miss, bright enough that nobody did. Astronomers had a baseline before Webb ever launched. Back in 2016, the Hubble Space Telescope spotted a galaxy called JWST, glowing just 400 million years after the Big Bang. Astronomers measure this in something called redshift. The bigger the number, the further back you're looking. JWST sat at 10.6. Strange, even then. Too bright for something that young. Webb was supposed to explain that away. Instead, in 2024, its survey called JWST found something even further back. JWST-GS-Z14-0, redshift 14.3. 290 million years after the Big Bang, and just as bright as it had no right to be. MOM-Z14 broke that record too. It just took until January 2026 to confirm it. 3 galaxies, each one earlier than the last, each one still burning like it had time it shouldn't have had. The part that should worry you a little, if you're the kind of person who wants the universe to make sense. At these distances, it is astonishingly easy to be fooled. In 2022, a candidate galaxy was announced at a redshift of 16. It would have shattered every record on this list. Then astronomers pointed a spectrograph at it, and the candidate collapsed to a redshift of under 5. Not the edge of time. Just a far more ordinary distant galaxy than the record books suggested. That is the mirage the survey's name is warning you about. So when the team found MOM-Z14, they didn't publish first and check later. A team of 46 astrophysicists pointed Webb's spectrograph, called NIR SPEC at it for 4 hours in the spring of 2025. Then they waited on the data, the way you wait on a test result you already suspect the answer to. Pascal Oesch, who co-leads the survey, put it simply: you can estimate a galaxy's distance from a picture. You have to follow up with detailed spectroscopy if you actually want to know what you're seeing and when. The spectrum came back unambiguous. Redshift 14.44. A miracle, not a mirage. Now here's the assumption that fell apart next. Before Webb, most models expected galaxies this early to still be small, loose clumps of the very first stars, not compact, chemically rich systems, already glowing at these brightness levels. A galaxy only 280 million years old shouldn't have had time to cook up much beyond hydrogen and helium. Heavier elements take generations of stars living and dying first. OM-Z14 is loaded with nitrogen, more than the timeline allows for, if the timeline is right. Rohan Naidu, the astronomer at MIT who led the team, found that same nitrogen signature somewhere unexpected, in a small fraction of the oldest surviving stars inside our own Milky Way. He compared it to archaeology, except here, instead of digging up a fossil and guessing its age, Webb lets you look directly at the living thing the fossil came from. Nobody has fully explained where that nitrogen came from. One idea: the crowded, dense conditions of the infant universe built stars far more massive than anything forming today. Stars that burned through a nitrogen budget in a fraction of the usual time. Then there's a second problem, worse than the first. MOM-Z14 is compact. A radius of 240 light-years is nothing. And packed inside that small A space is something like 100 million times the mass of the Sun. It's one of a whole class of these too bright galaxies. A class that keeps showing up about 100 times more often than the models ever predicted. That's not a rounding error. That's 100 times too many of them. One of the researchers on the team put it plainly: there is a growing chasm between theory and observation in the early universe. Not a gap, a chasm. And it isn't one strange galaxy causing it. Similar, unexpectedly bright galaxies keep turning up across Webb's deep surveys. Some astronomers think that gap closes quietly. Star formation in the infant universe simply turns out to have been far more efficient than anyone modeled, and the numbers settle down eventually. Others aren't so sure it closes quietly at all. A few have started asking, carefully, whether something is missing from the standard model of cosmology itself. Nobody is claiming that yet. Nobody's ruling it out either. And the galaxy isn't just sitting there being impossibly bright. It's changing the space around it. The gas surrounding MOM-Z14 is almost completely free of dust. That let its most energetic light escape outward and start clearing the thick, primordial hydrogen fog left over from the universe's dark ages. Astronomers call that clearing process rionization. Webb was partly built to find out when it started. MOM-Z14 says it was lifting earlier and faster than anyone's models expected. The clearing of that fog is a process, not a single event. It happens galaxy by galaxy, bubble by bubble, over hundreds of millions of years. What we are looking at right now is one of the earliest of those bubbles anyone has ever caught in the act of opening. So here's the question nobody on that team can currently answer. How does a galaxy get this massive, this bright, this chemically rich in under 300 million years? Every model of star formation says it needs considerably longer. We don't know yet. and that not knowing is the actual finding. Webb keeps turning up more of these, which means GN-Z11 was never a fluke, and neither was JADES-GS-Z14-0. Something about the early universe built galaxies faster than current physics allows for. Nobody in that collaboration is pretending otherwise. MOM-Z14 has been sitting out there, wherever it actually is, for 13.5 billion years, entirely unbothered by whether we ever found it. So, that number, 13.5 billion years, is how long the light took to reach us. It was never the distance. Space did not hold still while that light was in transit. It kept expanding the entire way, for the entire trip. Run the number the way astronomers actually run it, and MOM-Z14 is not 13.5 billion light-years from Earth. Right now, today, it is about 34 billion light-years away. We just spent this whole video looking at where the oldest known galaxy used to be. It spent 13 billion years outrunning its own light to get there.